For question 4, we're going to return to vectors. So you'll notice in this question we've got v as a vector, it's got an I component and a j component, but otherwise these work exactly the same as any other components. We're given some starting conditions that t equals 0 are at this vector here, and we're told that point P is when t equals 4. So point S is when t equals 4. The first thing we're asked to do is calculate the magnitude of the force that's acting on this 0.4 kilograms in order to produce this velocity. So we're going to use acceleration as our link between velocity and force, because I can differentiate this to get acceleration and then use F equals ma to pair these two up. So my first step is going to be to differentiate. So I've written down my function here and I'm going to differentiate it. So I get a is the derivative, so d by dt, of velocity. If we differentiate this, we get 6i plus 2tj. So this differentiates to give you 6, this differentiates to, oh, I need a plus 3 in here. 2t plus 3j. Almost missed that. So what we need to do now is to sub in t equals 4 to get a equals 6i plus, we sub this in, we get 11j. So this is acceleration, and we're asked to find the force, or the size of the force. So we're going to use F equals ma, where F and A are forces, and mass we're given in the question is 0.4. So this tells us that our force equals 0.4 times our acceleration, which is 6i plus 11j. Multiplying out the brackets, we get 2.4i plus 4.4j as our force. If we go back to the question very quickly to make sure we've done the right thing, we're actually asked to find the magnitude or size of the force. So you remember back from year 1 pure, we can find the magnitude of a vector just by using Pythagoras. So we get mod f is the square root of 2.4 squared plus 4.4 squared, which is approximately equal to 5 newtons. So we get our force. It's very close to 5 newtons when you put it in a calculator, but because in mechanics we give it to 2 or 3 significant figures, we should really write this in as 5.0 newtons. So that's our 2 significant figure answer. For part B, if we return to the question, we're asked to find the distance from O to S. So O is our origin. O is the origin. Don't think it explicitly says in here anyway, but we're going to call O our origin. And point S is where t equals 4. So in order to get distance, we're going to have to use integration. We use differentiation to get acceleration. We're going to use integration to get to displacement, and then we're going to use that to find distance. So we're going to integrate this, remembering that we've got vectors. So we're going to get s, the displacement, equals, I'm going to integrate the thing we had up here. So we're going to get the integral of v dt, which is 6t squared over 2 plus 4t for the i's, plus, and then we're going to have 1/3 t cubed plus 3 over 2 t squared j, and then we need a constant, and actually because we've got an integral with an I in it and an integral with a j in it, we need a c1i plus a c2j. So we need a constant for each of our vector terms, because this integral here could have produced a constant which would be hit by the I and become an I vector. This one here would have had a constant that would be hit by a j, and we get it here. These could of course be 0, but we need to take into account the fact they could be there. We're going to go back to our initial conditions. Our initial conditions I wrote up here, which is t equals 0, s equals this. So if I write in my minus 3i plus 4j equals, and then we cancel it, we're going to simplify this, so I get 3t squared plus 4t I, and remember, for initially we're going to get this equals 0, so this is actually going to equal 0. We're going to have our 1/3 t cubed plus 3 over 2 t squared, which is also going to equal 0. We're going to have our c1i plus our c2j. Comparing these up, once these are both 0, there should be a j in here. we get -3 is C1, and we get -4, so we get C2 equals 4, because we've got 4j here and C2j here, so we get C2 equals 4. Finally, we're asked to find the distance from the origin at t equals 4. So distance. We're going to substitute in t equals 4 into our expression here with these put in. So we get s equals, subbing in 4 in here, we get 3 times 16 plus 16 from 4 times 4 I, plus we get 64 over 3 plus 3 over 2 times 16 j minus 3i plus 4j. So this is our constant term that we found at the end, our constant of integration. We now need to turn this into a single number for I and a single number for j, and use Pythagoras to find its length. So s, our vector, is going to be, once we add up these things, we're going to get 48 for here plus another 16, which is 64, and the -3 here, which is 61i. So we've got 64 from here, take away this 3, don't forget this 3 on the end. We're now going to tidy up these numbers, which if you do it, I think we use a calculator for this. So we get 64 over 3 plus 1.5, 3 over 2 times 16. This gives us this. We need to add on 4 to this for this bit here, so we get 148 over 3 plus 148 over 3j. Once we've got this, we now need to turn this into a distance. So mod s is the square root of 61 squared plus 148 over 3 squared. If we do this and then we square root it, so I'm going to take this, I'm going to square it, I'm going to add on 61 squared, and then I'm going to square root my answer, which gives me 78.45 meters. Because it's mechanics, I'm going to give this answer as 78 meters, remembering that we give all our answers to 2 or 3 significant figures.